Greetings, this is Arachnith Codes with another roguelike library tutorial. This time we're going back in time a little bit. We're discussing BearLibTerminal, which is, I believe, one of the oldest libraries for C. It's been around a while. I can't remember if it was before or after the very popular libtcod library, but this is actually the first library I learned to use. Um, I used this before I used tcod. It is very bare bones. It is merely a display terminal. It is not. It does not have a lot of the roguelike functionality that tcod does. I prefer it to tcod for writing in C simply because, especially now, it's got a little bit of a simpler workflow, and when I'm working with C. Um, Here is the website. I will include it in the description. I will go back to the top so you see everything. This is the website for it. Documentation's very simple. It's a very simple API. Actually, hold on. I will actually go to the API. The API fits on not a lot of website. This is the whole API. It's fairly simple. There's not there is a lot and there isn't a lot to it. There aren't a lot of different functions to memorize. It's a very simple API. It's all included right here, right there. That's the API. Okay, now for insofar as the tools I'm using to put this together, because let's face it, we're talking about C and C++ and Windows, so we've got to have a little bit of a tool chain. I will be using Visual Studio Code as my editor. I like Visual Studio Code. I like it a lot. I especially like the CMake and C++ extensions that make working with C++ files and toolchains very simple. And and the CMake tools require CMake, so we will be using CMake. Also, I like CMake because it is cross-platform. You can write a CMake file that will generate files for whatever platform you need it to with one file if you really want to go that far. So I like CMake. It's easier to deal with make files or Visual Studio. It's just I like this combination, and that's the combination we'll be using today. All right. So the first thing we're going to do here is we're going to get BLT set up. We're going to download it, and there are pre-built binaries, and we will be using said pre-built binaries because, with very few exceptions, the pre-built binaries just work. The only case I found it didn't work was when I tried to do this on my Raspberry Pi. I actually had to build it from source on my Raspberry Pi to get it to work, but for basically anything else, they're pre-built binaries. I will download the Windows version here. As you can see, I have already done this many times. And we're going to extract this. I'm going to extract this to a folder. Aha. I was supposed to remove that to pretend we hadn't done this before. Anyway, we're going to extract this folder to place on your computer. You're going to need to know the path, so put it somewhere comfortable. I'm going to rename this to BLT. Let's take a tour of the folder. Now, these are, again, the Windows binaries. The include and media folders will not change. This will be Linux 32 and Linux 64 if you download it for Linux. I do not know what it will be in Mac OS because I do not have a Mac OS machine to test. In the include folder, we will find folders for many different bindings of BearLibTerminal. You can actually use the DLL or the .so with many different programming languages and bind directly to it. I do not recommend the Python binding. I think the Python binding is a little slow. The binding that we care about is C. That's the language we'll be doing. We'll be writing in, and we will need this BearLibTerminal.h. Same with C++. This is the header file you'll need. In the media folder, you will find various fonts and tile sets in bitmap and PNG format and images. These are used not only by the sample program that we will take a look at in a moment, but we can also copy these into the folder to use ourselves, and having this set of assets is actually pretty nice to test and develop with. The Windows 32 and 64 folders contain the same files. They contain a DLL with the appropriate architecture. They contain a .lib file. If you are using the NVSC compiler, as I will, you will need this .lib file. If you are using Cygwin or MinGW as your compiler, you only need a DLL. You don't need to worry about this lib file in that case. Also importantly, you'll have the sample omni.exe, which again I recommend running. Just brings up some samples, and you can actually just get some very well written samples on BearLibTerminal, and if nothing else, it confirms that everything is working, that everything is sane, that you have your DLL. Basically just confirms that everything is working alongside the DLL, that you're not missing any critical system libraries, anything like that. So yes, first step here, once you download, should be to open the sample Omni, make sure it's working, and if it's not, honestly, probably beyond the scope of this tutorial to really troubleshoot. But that's the first thing you should check to make sure that's working. Now we've got this. We're gonna close it, and we're gonna open Visual Studio and actually get cracking on getting BearLibTerminal set up. So we're gonna be silly is actually what's gonna happen. We're going to create our tutorial folder. I think I've already created it. I did already create it. Okay, so we've got our tutorial folder. We're gonna open our fresh folder that has nothing in it. I swear it has nothing in it. Yes, this is not the first take. So the first thing we're going to do is we're going to make a CMake list file. Actually, instead of manually creating the file like I had in previous takes, we're actually going to show off one of the cool features of CMake tools. By the way, extensions you need. You want the Microsoft extension pack and the CMake tools extension. These two extensions will make your life much easier when working with C++ and C and CMake. They power this tutorial, so make sure you have those extensions if you're following along. Now, we're going to hit F1, and then we're going to hit CMake Quick Start. And then we're going to call this project BLT_tutorial, and it's executable. And we're going to close this, and then we're going to allow here, and CMake is going to do its CMake thing and give us a minimal CMake file. And in fact, at this point, if we press play down here and run this, it will build the file, and we will get a hello world, and that will confirm that all of our CMake tools are running, and that's all good. Now that we have all that, we're going to get rid of most of this. We're going to get rid of pretty much all of this, except this. We're just going to get rid of that. We're also going to be renaming main.cpp to main.c because I prefer to use C. I think C++ is a little bit arcane for what I want out of an object-oriented programming language. Okay. Anyway, gripes with C aside, let's get cracking. So, the first thing we're going to do is just I'm going to be terrible at CMake. There's many different ways you can do this. I would make a folder and set up the globbing of files together so that it would find the changes in all the files and all that. But we're not about that life. This is a very simple. This is a basic tutorial to get up and running. We're not trying to be all complicated. We are, however, going to do a little bit of don't repeat yourself, and we're gonna set our BLT folder to standalone BLT, which is the folder, as you will recall, that we put all of our BearLibTerminal stuff in. We're going to wind up using this a lot, so we're just going to set a variable for it. Okay. Now, because we're doing this the double hard way, well, maybe not the double hard way, because we are doing this with a library that we manually pre-downloaded instead of something that we're going to fetch from somewhere. We need to tell BearLibTerminal. We need to tell BearLibTerminal? No, we don't. We need to tell CMake where to find our files to link. So we will use a find library, and we will call this variable BLTLib, and it is BearLibTerminal.lib, because again we're using an MVSC compiler, which requires the libraries to be in lib folder files. So that's what that will actually use to build, and we can find it in our BLT folder, and we're using the Windows 64. And just to confirm that everything is found, we will print a message. If it's not found, it will say BLT not found, and then we'll let you know that's a problem. Next, we will find a path. We need to tell CMake where the header file is. So we'll call this file path. Change this to header.h, and this will be in the include C folder. And much like before, we will get a message. Okay, and that will tell us that we found the header, and we're going to do this again with the actual binary, because again we're working in Windows, so we have to copy the actual binary over to the directory when we're done, because it's a shared library, which means the library is not going to get compiled into the executable but linked afterwards. And this too is in Windows 64. Okay, we have those set up. Now we need to add the executable. I actually thought we had this. I removed it. Okay, anyway. Tell it where the sources are, like libraries. This file is also, like, again, it's set up for the minimum of repetition so that it's very easy to change stuff around if you need to change stuff. And I'm going to need to tell it where the include directories are. Linux. And also the current directory. Actually, really, if I were really being technical, it would be CMake current source directory. Okay. And we've now told CMake where to link and that it needs to link. And now we need to tell CMake to copy the binary DLL to the output folder, and we will do that with an add custom command. And this is where the binary folder comes in. We'll use a called generator expressions. Okay, we save this. Configuration is done. Finds interesting that it did not. I mean, it did. Oh, I used the wrong variable for this. Okay, there we go. Now, we've confirmed that we found the library, and we've got paths for the header and the binary. Everything is generated, everything is good. Now on to the good stuff. Now, we are in C, not C++. If you can find BearLibTerminal.h with IntelliSense, you do. That is one check you can make that your CMake file is correct. And we'll remove that. Okay. All right. Getting all that nasty C++ out of there. Okay. So in BearLibTerminal, a couple concepts we need to go over. Let's set up some variables. So, in BearLibTerminal, first things you need to do before you can do any work in the terminal, first thing you need to do is open a terminal. The last thing you need to do is close it. So now we'll print the message that we have. That's done with terminal print. Takes an X, a Y, and a pointer to a char. Now, in BearLibTerminal, the coordinates follow standard computer graphics coordinates. That is, 0, 0 is at the upper left corner. X increases as you go right, and Y increases as you go down. So the origin is in the upper left-hand corner. That's important to note. And in BearLibTerminal, after you make any changes to the console to get them to appear, you have to do a terminal refresh. You also need to do a terminal refresh before you perform any input checking, which we're about to do right now. tk-close is one of many event and key constants. Terminal read is a function that waits for user input before responding to it. It's a common feature of older, especially older roguelikes, that would allow you to simply just sit there and take your time and think about your move, and they wouldn't respond to you would. And so a very easy way to get that effect is by using terminal read. This blocks, it just waits for your input, and then it returns the constant that corresponds to the event that happened. It might be a key press, it might be a mouse movement, it might be a mouse click, it might be a, oh, actually I'm not sure this responds to mouse clicks exactly. This does respond to key keys and keyboard movements. There's other ways to check mouse clicks. Maybe in a future video I'll go over exactly how that works. But this key will be set to whatever the key code of whatever was pressed or clicked. And if it is, as long as it's not TK close, then this loop will keep going. This will just let stuff stay on the screen for us. And then finally, after we get out of this loop, terminal close happens, returns all the resources to the operating system, and then we return from the function. So let's have a look and see what happens when I click the play button down here. Again, that's a nice little feature of CMake tools. It runs the CMake, it builds everything, puts everything together, and then you get a nice hello world BearLibTerminal. And as you see, nothing is happening right now, but it closes when I close it. And that sounds strange to say, but without this code, that wouldn't actually happen. It would just stay up until I manually killed it. All right. Anyway, that's going to do it for basic setup for BearLibTerminal. There will be a part 2 that will discuss a little bit more in depth things like input and possibly going over how to change the font that's used and the screen size. Maybe a little bit of configuration. But that will do it for now. Thank you for joining me, and I'll see you in the next one.